Okay, now the humidification and the related saturation problems. Of course, whatever the learning you make for the air-water equilibrium, you can also apply for air and any other condensable component. If it is air-water, we call it as humidification. If it is like air and any other vapor, so we call it as saturation problem. Okay, that's it. So relative saturation simply refers to the relative humidity. So what is the formula for relative humidity? We say like partial pressure of water vapor divided by vapor pressure of water vapor. In place of water vapor, it is going to be some organic component. And the partial pressure is simply mole fraction of the component multiplied by the total pressure. That's it. So here it is about getting the percentage of air in this air ethyl acetate vapor mixture and the percentage saturation of ethyl acetate in this ethyl acetate air system. Okay. So first thing is percentage of air. For that, we are given with this relative saturation, which means similar to relative humidity, which is partial pressure divided by vapor pressure. So partial pressure is mole fraction multiplied by the total pressure. So we are given with the total pressure in kilonewton per meter square, and this vapor pressure also available. So from that, we are getting this mole fraction of this ethyl acetate in the air ethyl acetate mixture. Okay, once this is available, you can we are asked to actually report the air percentage. So this is percentage of air. So percentage of this fraction of state is 0.08 and the balance is what air. Actually, this is now equal to 92%. And percentage saturation is similar to percentage humidity formula, so which is actually the humidity divided by humidity at saturation. The humidity actually refers to this partial pressure of this condensable and partial pressure of the non-condensing component. Simply here it is actually air. Now in place of air, sometimes we can also have like O2, N2, that also they are not going to condense. Always like ethyl acetate in O2. So ethyl acetate is a condensable component. O2 or N2, these are all non-condensable. So numerator is condensing, denominator is non-condensing. Okay. So this is the definition of actually humidity. Here actually in terms of actually there is no terminology here. Okay. Percentage saturation is actually the partial pressure of the condensable divided by partial pressure of non-condensing. This is partial pressure of that condensing divided by non-condensing at saturation. Okay, so this is at saturation, here at the actual conditions. Okay, we are given with this PA bar, which is actually this YA into P, which is simply 0.08 into P. So from that we have denominator is actually saturation pressure, which is actually it is to be written as PA, not bar. The bar we and all we won't have for saturation. Actually, simply we can say like PA also, but since many times we are using like partial pressure as bar, okay, we'll use this PA bar. PA bar refers to YA into P. Okay, that's it. Okay, so from that now actually we are going to get percentage saturation. So percentage saturation is what is it? Partial pressure divided by partial pressure of the air, and this is partial pressure of component divided by partial pressure of air. This is actually at saturation, saturation of the condensable component.